Hello, welcome again to the Software Defined Radio 101 with RTL SDR. On this module 3, we will see some advanced features of the SDR. This example is how to receive frequency modulated signals. First, let's talk about frequency modulation. Frequency modulation is a type of modulation when the carrier shifts in frequency in line with the modulation. So the modulator signal is changing the frequency of the carrier. The main parameter of the FM modulation is the level of modulation called frequency deviation. We can define two types of frequency modulation signals, low level and high level. Low level of deviation are called narrow band frequency modulation, and these typical levels are plus minus 3 kHz deviation. These types of modulation is used for point-to-point communication, for private service, police, and any other analog service. High-level modulation deviation are called wideband frequency modulation. This is mainly used for broadcasting, and they use 75 kHz frequency deviation. We are going to do now an example for receiving broadcast FM modulated signals. The main element of the modulation of FM signals is the FM demodulator. This used to be an analog circuit that converts frequency variations to voltage variations, then provides an output voltage proportional to the frequency shift. The ideal response is a perfectly linear voltage frequency to voltage characteristics. The FM demodulator used in Simulink is completely different. This type of demodulator demodulates a sample of frame-based complex input signal. This is the block diagram of the element, and it has only one parameter, which is the frequency shift. On this example, we have put 75 kHz. Internally, the Simulink demodulator uses a delayed and conjugate copy of the received signal, I of t, and this complex and conjugate is multiplied, is subtracted from the signal itself, obtaining a WT signal. The output, V function of t, is a signal whose amplitude depends on the frequency difference. Then the signal V of time is the approximate derivative of the frequency of I of t. Okay, so this is the way of doing one of the ways of doing a demodulator, and this way is used by Simulink. This is an example of a complete RTL SDR receiver. The complete receiver has here the radio software module with all their parameters, and here we have put a control to input the center frequency, the receiving center frequency. This is very helpful for tuning the desired broadcasting transmission. Then we have put the FM demodulator, baseband FM demodulator. Simulink has also passband demodulator, but here RTL SDR gives a baseband output. And then we have two filters. The first filter is a low-pass filter that we call the emphasis filter. This is because the FM demodulator has a high-pass response, and then it's necessary to equalize the response with a filter. And the other filter is a decimation filter. This is to adapt the sampling rate of the SDR, that here is higher, is 1 megasamples per second, to the sampling rate of the audio device, which is around 100 kHz. Then we connect a spectrum analyzer on this point to see the received signal. Here is the configuration of the RTL. We have put the sampling rate 1 MHz. We have the automatic gain control on, and we put a number of samples per frame, 1280, which is a normal number, and we have a control called slider gain. This slider gain, here we use to tune the center frequency of the RTL. We have marked this control, and then we can shift the frequency while the simulation is running. Then here we have the spectrum analyzer and the parameters of the FM demodulator, 75 kHz for FM broadcasting. This is the emphasis filter. This filter has been modeled to attenuate the high pass frequencies and let passing the lower frequencies. So it's a low pass response, and it equalizes the modulated signal. It's used in all the FM receivers. And finally, the decimation filter. It adapts the sampling speed of the demodulator to the sampling speed of the audio device. It has 3 parameters: interpolation factor, which is not used here, is given to 1. The number of filter coefficients, which is not very relevant here, 5 to 10. And the important value is the decimation factor. It must be a value that is accepted by the audio device. Typically, an audio device uses 100 kHz of sampling frequency. Finally, the audio device. This is the first time using the audio device, and it has some parameters. The most important is the sampling rate. The best here is to mark this point, and then it takes the sampling rate coming from the input signal. Okay, let's see the example working. Here we have the complete receiver with all the parameters. We can execute and see the frequency modulated signal. Then here we have one receiving signal. We can shift the frequency moving the slice bar and tune different signals. And we can switch on the audio device and we can hear the modulated signal. This is one type of signal. And here we have tuned this signal. We can remove the emphasis filter and try to see the difference of using it or not using it. We do comment through, and then now we don't have the emphasis filter. And now the sound has lower quality. We have removed the lower frequencies, and we can see that it sounds completely different. We connect again. And we can see that now the quality is good. So it's important on all these FM circuits, as they have a low pass response, a high pass response, it's important to make a low pass filter after the demodulator to equalize the response. And that's all for today. Thanks for your attention.